Good morning, fabulous fives all over South Africa. Lovely to have you with us again this morning. Welcome. We started looking at fractions last time, and we're going to continue our journey through fractions. I mentioned at the start of last lesson, when I sent you off to get a pencil and paper if you didn't have with you, I mentioned how important times tables and mental arithmetic are, and I just wanted to quickly go onto that just again to say that, for example, one of the girls that I teach had a short test of 10 multiplication problems this morning, and she got 7 out of 10, which was very good. But interestingly enough, the 3 that she got wrong was not because she didn't know how to do multiplication. It was because she made small times table errors when she was working out her answers. And so actually, if she'd been a little bit more fluent with her times tables, she would have got 10 out of 10. And that's what I mean why times tables are so important, and times tables and mental arithmetic. So what I mean by mental arithmetic is, for example, if I say, what is 8 plus 7? You shouldn't have to count on your fingers. You should just be able to say 15 straight up. All right, so that's what I mean. And as a sort of a short little challenge, what I thought I would do is start off by doing those times tables. And I've been out of school a very, very long time, but I do still remember when we learned times tables at school, our teacher would say to us, all right, you have to learn, say, the 5 and the 7 times table. You have to practice them for tomorrow. And then he would call somebody up, and you had to stand in front of the class and recite your times table. And although it terrified me at the time, I'm really glad that he did it. And I've managed to remember my times tables since then, and I find it very useful to know. So I'm going to set a challenge for you. I'm going to switch across to my whiteboard. I'm going to get my phone out, but only so that I can time myself. And I'm going to time myself doing the times tables, but I'm going to do them nice and slowly and clearly. So this is a challenge to see if afterwards you can go off and test for yourself who can do it faster. All right, so you can see I've got it up there, the 2 times table. I will look at the camera so that you can see I'm not looking at anything else. I'm not cheating. Okay, so let me just push start on my stopwatch. Okay, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. All right, so 13 seconds for my 2 times table. Let's do the 3 and go. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. 12 seconds. All right, maybe, I don't think I should do all my times tables today. It'll take a little bit long. Let me jump forward and let's do the 7 and then the 8. We'll do 3 more, maybe the 11 as well. All right, so the 7 times table. Reset and start. 7, 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84. 12 seconds. Whoops, wrong place. That was the 7 times table. Right, let's do 9. Right, and go. 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, 99, 108. 11 seconds. Okay, and let me just do, well, that's enough for today. All right, so I'll set that challenge. So the challenge for you is, are you able to go faster than me, or at least close? But if you aren't, why don't you set yourself a target? So do your set today, so do your times table, and however long it takes, make a note of it, and then practice it a bit and see if tomorrow you can go a little bit faster. All right, okay, let's jump across to our presentation, jump in. So just a reminder, if you have any questions, you can email me on grade5@worksheetcloud.com. If it's relevant to the lesson, I'll see if I can answer it in the lesson or in next lesson. And if it's just something that you need to know, then I'll reply to your email. All right. Okay. And also a reminder that the homework is on this page. It's the link just above the lesson, and you can get that after the lesson. Okay, fractions. So today we're going to look at comparing fractions and equivalent fractions. So get that out the way quickly. Let's put it up there. All right, so today's lesson goals, we're going to see that we can show the same amount of something as a different fraction, so the same fraction using different numbers. We're going to understand how to order fractions if the numerators are all the same or if the denominators are all the same. And finally, we're going to start looking at how to compare fractions when the numerators and the denominators are all different numbers. How do we then organize them from smallest to biggest or biggest to smallest? But I thought what I'd start with is just a quick recap on why we have fractions and a snack for me. So let me switch back to my camera. Let me maybe drop this down a little bit here. So I have some chocolates. It's maybe a little early for chocolates. Nah, it's never too early for chocolates. So let's imagine that myself and 5 friends, so 6 of us all together, wanted to share out these 6 chocolates. Well, that's pretty straightforward. There we go. We each get 1. Nice and simple. I think if I set you a task later on today, I might just take that opportunity to eat one of those. But perhaps I'm having a healthy day. And instead of getting Lindor balls in my lunchbox, I get an apple. Now, unlike the Lindor balls where I could share them out and we could each get 1 because I had lots, I now only have 1 thing and I needed to share it 6 ways. And that's really why we have fractions. It's when we need to break up single things, 1 unit, and we need to break them up so that we can share them out. All right, so that's the reason why we have fractions. And you can see I've now shared it out so that each of myself and my 5 friends can each have a piece of apple. And I'm sure that most of you are wishing you part of my group of friends when I'm sharing out the Lindor balls. But there we go. Okay, so back with me, and let's jump back into the presentation. Okay, let's work quickly through the homework from yesterday, just to check that you're on track. So I will go through the homework. You did have a memo, but maybe it's useful if you go through with how I got the things that I got, or the answers that I got. All right, so let me actually drag that a little bit down here. We can expand it. That's a picture of the homework from yesterday. I'm just going to open up on my iPad so that I can draw a little bit. Okay, so in the first question, it asks you to draw those fractions. Now, when we're drawing a fraction, it doesn't matter what shape it is that you draw. I'm going to choose to draw, let's see, I think I will draw squares because it's probably a little bit hard to draw a circle without using a compass. All right, so let's pick a nice cheerful color for now. I'm going to use a square. I'm going to break it up into 6 pieces. All right, and that's because my denominator was 6, so that's why I have 6 pieces. And now to decide how many I color in, I then look at the numerator. So 3 are colored in. It doesn't matter which 3 you color in. Just for fun, I'll do it like that. So there is my drawn fraction for the first one. For the second one, I'm going to use a square again. We'll pretend that those are all nice and neat. And again, I look at the numerator, the top one, to find out how many I should color in. 2. And there we go. There's my 2 out of 8, 2/8. For the last one of question 1, we're breaking it up into 4 pieces because the denominator was 4. And we are coloring in 1. So there we go. I hope yours were much neater and that you used a ruler. Good piece of advice, always use a ruler when you're drawing, especially in math. Well, not if you're doing art, but if you're doing technical drawings or maths, you should always use a ruler. Otherwise, your teachers will get annoyed with you. Okay, when I say name the following, I want you to write it down as a fraction. I think we can switch to a different color. So if we look at the first one, we can see that there are 5 pieces. Right, 1 is colored in, so we get 1/5. The one underneath that, there's 6 pieces. Denominator is 6. 1 is colored in. 1/6. The next one, we've got 2 pieces. 1 is colored in. 1/2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10. 1 is colored in. So in each of these, 1 was colored in. So your numerators all got to be the same. Anyway, we'll come back to comparing them to see which is bigger later on, where numerators are all the same. Okay, so 1, 2, 3, 4, 5, that's 12. Incidentally, 12 is the greatest one of the, or not the greatest, the smallest fraction that you're expected to really be able to work with at a grade 5 level. And the last one, we have 4 pieces. 1 is colored in, so 1/4. And finally, we have a word problem. And I think with word problems, it's useful to pick out the important information. So first of all, I'm going to underline it. So you need to share a slab of chocolate with 6 people. And it was a slab. So another way of saying a slab is 1 slab and 6 people. So we need to break that up into 6 pieces. So 1 slab. Oh, I can see I've gone off the bottom of the page. Let me rather do that on the right-hand side. So we have 1 slab shared between 6 people. All right, there's the fraction. And because it's a word problem, we should always write a word answer. So each person gets 1/6 of a slab of chocolate. Right, move that just a little bit up. There we go. So each person gets 1/6 of a slab of chocolate. All right, that was the homework from yesterday. I hope you didn't struggle with that at all. Let's jump back into the lesson for today. Okay, so organizing fractions with the same numerators but different denominators. Okay, so again, I'm not going to go into presentation mode because I'm going to jump across to my whiteboard. Having a look over here. Nope. Having a look over here. Let's move them around a bit. All right, so we've got a situation here where we need to organize these. And let's say we want to organize them from the biggest to the smallest. So first of all, we're looking at organizing one's fractions that have the same numerator. So in each of these, we can see there's different number of pieces there, but each of them only have 1 colored in. So that means the numerator for each of those fractions would be 1. So let's organize it from biggest to smallest. So if I look at these, this, where I can see this whole piece is colored in, I'd say that's the biggest. So I'm going to put that on the left. What would be the next biggest? Which one of those? Definitely that one. Think that one would be next. Oh, now it gets a little bit harder, but I would say that one. Oh, I can't quite see between these. Let's count. Well, 6 pieces, 8 pieces, 7 pieces. So 6 pieces would be the first one. And there we go. We've organized them from biggest in terms of fraction, biggest piece of the circle down to the smallest piece of the circle. But let's have a look at that in how we would write the actual fraction. Right, so not just looking at the picture of the fraction, but the numbers of the fraction. All right. Okay, well, the first one, there are two pieces. So 2 at the bottom, 1's colored in. Remember I said all of these only have 1 colored in, so the numerator for each is going to be 1. Okay, how many pieces in the second? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this brings us to probably one of the most important things you're going to learn this lesson, and that is this. If we look at this last one here, the bigger the number at the bottom, so the bigger the denominator, the smaller the actual fraction of the circle. Right? And we sort of think of bigger numbers mean bigger pieces, or generally greater numbers are bigger. But when we're talking about this, it's because the denominator, this number here, shows us how many pieces the circle's broken into. In other words, the more pieces it's broken into, the smaller it is. So we can see that this is the biggest on the left, going down to the smallest on the right. All right, so we've organized our fractions from biggest to smallest, but it looks, if we look at our numbers underneath, the denominators are going from the smallest number up to the biggest. And as I said, and I'm going to repeat again probably a couple of times this lesson, that's because the denominator shows us how many pieces. So the more pieces we break something into, the smaller it is. Okay, now I'm going to jump across. I'm not going to go back to the presentation. I'm just going to move over to the other numbers I've got over here. All right, and this time we're looking at pieces that have the same denominator but different numerators. Right, so you can see that each of these is broken up into 6 pieces, so the denominator is always going to be 6. And this time let's organize it from the smallest fraction to the biggest. So I think it's easy to see that this one here, the smallest piece of the circle, is there. I think that one would definitely be next. That one have to go after that. That one, and finally that one. The whole circle is colored in, so that's definitely the biggest. So we've organized it from smallest to biggest. All right, okay, let's have a look at if we write those out in numbers though. All right, well, our denominator is going to be 6 for all of them because each of them have 6 pieces. So we can go ahead and put all of the denominators in. Right, and now we just need to look at how many pieces are colored in. 1 piece is colored in, 2 are colored in, 3, 4, 5, and 6. Right, so we can see that now if our denominators are all the same, all we need to do is look at our numerators and we just organize them according to size like that. All right, so we've gone from smallest. So in the previous one, we went from biggest to smallest. This time just very different. We went from smallest to biggest. All right, so we went from the smallest on the left to the biggest on the right, the smallest piece of a circle to the biggest of a circle. All right, so that's organizing them from according to the numerators when all of our denominators are the same. Okay, let's move me down a bit. All right, so this is what we did now. We organized fractions with different numerators, but with the same denominator. Okay, so have you noticed that sometimes when we have what looks like the same size pieces, but we use different numbers? Have you noticed that? I hope so. We've looked at a few different things. So if we look at this, for example, I can stay there for now. All right, so if we look at this, for example, over here, we have this whole piece, or half, so that would be 1/2. And then over here, I've got 2 colored in and I've got 4, but these actually look the same size, don't they? And this is the same size as this, if we just turn this one around. And this one is the same size as this if we just turned it a quarter of a circle. Let's have a quick look at that in our drawing board. I think I have them over here. Yeah, there we go. All right, so as I said, we were looking at them in, just move my iPad across. All right, so we were having a look at these numbers in the slide, but let me write down what the fraction is. So if we look at the first one, we can see for this one here, we have a denominator of 2, a numerator of 1. If we look at the one just to the side of that, we have a denominator of 4 and a numerator of 2. And that's the same for this one here. We've got a denominator of 4 and a numerator of 2. But those are actually the same size, which means that 1/2 is equal to 2/4. So 1/2 is equal to 2/4. And if we look over on the other side, we can see the first one, we've got 1/3. And if we look down here, the one below it, we've got 2/6. And again, those are equal to each other. So that means that these are different ways of showing the same fraction. So this number and this number show the same pieces, or show the same size, same amount of a circle. All right, so each of them have that amount of the circle colored in, which is the same, but we've used different numbers. And we'll spend some time converting between different fractions and learn how to do that. But the reason why we do this is because sometimes we come across situations where actually we need to be able to change one of our fractions, because we can't necessarily be able to tell which is bigger or which is smaller. So as an example, I hope I'm on the right spot. If I had a fraction of 3/5 and I had another fraction of 7/10, and I wanted to know which one of those were bigger, that would be quite difficult. Well, we could draw them, I suppose, but how do we go about finding out which one is bigger? And very simply, what we need to do is we need to change them to have the same denominator. Right, so in order to compare them, to organize them from smallest to biggest, or biggest to smallest, or just to say which one is bigger, we need to be able to make the denominators, the bottom number, the same. Right, so how do we go about that? Well, before I do that, let me just put this into a real life example. Perhaps your brother or sister comes to you with a chocolate and they say to you, would you like 3/5 of this chocolate, or would you like 7/10 of this chocolate? And I assume you love chocolate, which is why you're going to want to get the bigger of those two pieces. So now we need to figure out which of these pieces that she's offering us, or he's offering us, is actually the bigger of the two pieces. Right, so what I'm going to do is I'm going to take a look at this one over here and this one over here. Right, I want to make the denominators the same. So I want to have the same number for this denominator as I do for this denominator. So what that means is I have to change one of those denominators. Now I hope that you can notice that 5 we times by 2 to get to 10. I don't know if you noticed that. There are 2 5s in 10. Right, so that gives me a thought. Right, I'm not going to do anything over there. Right, but what I want to do is I think I'm going to try and turn this denominator into 10. So what can I do to a 5 to make it into a 10? I can times it by 2. And grade 5s, you're about to witness something that is probably the closest I will ever come to being on idols or singing in public. And that is the little song that I've tortured my past students with, but they all remember. And that is, what you do to the bottom, you do to the top. What you do to the top, you do to the bottom. What you do to the bottom, you do to the top. And by that, what I mean is, because we've times the bottom by 2, we're going to times the top by 2 as well. So I'm doing this as a number now. In a moment, I'm going to show you the same thing as a fraction, and you'll see how, as a picture, and you'll see how it makes sense. But first of all, let's change this fraction. So if I have a look up at the top, I'm going 3 times 2, that gives me 6. And at the bottom, I'm going 5 times 2, which gives me 10. So I've taken this fraction and I've turned it into that. That is the same amount. That's why we have an equivalent fraction. And now you'll be able to see, I'm not changing this one. This stays the same. It's now very easy to see which one of those two is the better deal, which one will give you more chocolate. Definitely 7/10 is better than 3/5. All right, but I do want to quickly draw that for you just so it makes a little bit more sense. Right, so a little bit down. Let's use a circle for this. Let's do my best circle. Okay, that's not too bad. Right, so let's make this into 5ths. Oops, sorry. So that's roughly, should be exactly, but that's roundabout the amount that I'm looking for. I'm looking for 3/5. So let's color in those 3/5. 1, 2, 3. Right, but that was the time when I realized, actually, I need to look at this in terms of tenths. And the way that I'm going to make my 5ths into tenths is to break each of them into half. That wasn't quite in the middle. All right, and if I have a look at this drawing again, you will see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, and 1, 2, 3, 4, 5, 6 are colored in. So I've got 6/10. So this is just me illustrating in a picture how we got to 6/10. All right, we are actually running out of time, so we're going to spend quite a bit of time practicing converting from one to the other, so finding equivalent fractions so that we can compare. We'll do quite a lot of that in the next lesson, so it'll be quite a practical lesson. So when you do come to the next lesson, please make sure that you bring a pencil and paper. All right, but having a look back at our presentation, as we've said, we look at equivalent fractions. So in this particular example, you can see that over here we have 2/4, which is the same actually as when we have 4/8 and the same as 1/2. Each of those is a different way of showing the same amount of a piece, or amount of the whole. So that's the whole square, and 2/4 of the whole square is the same as half of the whole square. Right, so recapping, just checking that we are on track, all the things that we've covered this lesson. So if all the numerators are the same, so the number at the top, if they're all the same, then we look at the bottom number, the denominator, and we work out, we can put them in order just according to the denominators. So just reminding you, the bigger the denominator, the smaller the piece, because we've broken up the whole number into more pieces. And if our numerators are different, but the denominators are all the same, then the bigger the number on top, the bigger the fraction. Okay, so this is what we looked at now. What if the numerators and denominators are both different? And how do we do that? We've had one example today, and we'll spend quite a lot of time on our next lesson having a look at that. Once you've got it, it's really not that difficult. Right, so just checking that we have covered the goals, that by now you should be able to do these things. So first of all, can you see that we can show the same amount of something as different fractions? That's looking at equivalent fractions. I hope you've understood how to organize if the denominators or if the numerators are the same, and maybe just an inkling of the last one, you'll be able to change simple fractions to equivalent fractions in order to compare them. We'll really cover that in a lot more detail in our next lesson. Okay, and that's pretty much the end of the lesson. Just a reminder that your homework can be found in the link at the top of the page. If you have any questions, please email me on grade5@worksheetcloud.com. I've had a good time this lesson. You've witnessed somebody singing. Reminder of your challenge to see how good you can get at doing your times tables. I'll set the times for the next ones, but really it's about you getting quicker. So set your own time, and tomorrow see if you can beat your own time. Remember, the first and most important thing is to get the numbers right at any speed. So first right and then getting them faster. That's for times tables. Okay, I think that right now is a good time to sign off and go and drink some tea and eat a piece of apple. Have a good day.